All right, so now we are going to learn how about non-homogeneous systems. Well, what we learn in chapter 4 is, let's say we have a non-homogeneous differential equation. How we solve it is, we first look at the homogeneous version of the differential equation. We use auxiliary equation method, for example, and we found y sub c, the complementary solution. Then we took the non-homogeneity into account, right? We found the particular solution, maybe using method of undetermined coefficient, variation of parameters, any method you like, and you add the complementary solution and the particular solution and you get the final general solution, right? Well, it's the same thing in systems too. Okay, all right, so let's say we have a non-homogeneous system. X prime is equal to ax plus f. What first you do is you solve the homogeneous version of the system, and then you get the complementary solution. Let's call it x sub c. Now you solve the particular, now you find the particular solution, so let's call it x sub p, and you add it to the complementary solution, and then you get the general solution. Okay, how to do that? That is a discussion for another chapter, but it's the same thing. Right now you can see the connection. Now what really the difference is, instead of functions, our solutions are again what? Vectors. Okay, and the complementary solution is made up with what? Fundamental set of solutions of x prime is equal to ax. So the solutions are vectors x1, x2 and x sub n. They are vectors, so you take the linear combination of these vectors, you can get the x sub c. Okay, all right, so let's look at an example quickly. We have a non-homogeneous differential equation here. X prime is equal to, well, ax plus f, where a is 2, 1, 1, negative 1, and f is actually the non-homogeneity is negative 5, 2. Okay, so that's the non-homogeneity. Now the particular solution is, they said xp is 1, 3. So you can see the particular solution is also a vector, okay, because our solutions are vectors now. The question asks whether whether this xp is in fact a particular solution. No. So it's sort of like a verification. So let's take the left hand side here and let's take x prime of xp prime. If you differentiate 1, 3, you get 0, 0 because they are constants, right? If you differentiate term by term. Now let's take ax plus f. So this will be, a is 2, 1, 1, negative 1. So I'm doing the right hand side. xp is 1, 3. You have to add negative 5, 2 to this. Now if you multiply these two here, 2 times 1 is 2, plus 3 times 1 is 3. Here 1 times 1 is 1. Negative 1 times 3 is negative 3. Plus negative 5, 2. I didn't touch this negative 5, 2 until the last moment, until I finished the matrix times vector. So 2 plus 3 is 5 here. 1 plus negative 3 is negative 2 here. So what would you get if you add these two? Well, 5 plus negative 5, you add row by element by row in the same row, 0. Negative 2 plus 2 is 0. So left hand side is 0, 0. Right hand side is 0, 0. They are the same. So this xp 1, 3 is in fact a particular solution because it satisfies the non-homogeneous differential equation. Okay, all right, so that is really very simple. It's the same thing what we learn in chapter 4, but in starting from the next section of this chapter, we are going to learn how to solve homogeneous linear system of differential equations. Okay, all right, see you, bye bye.